Okay, welcome to week 3. I'm sorry for being absent last week. I hope my recorded video was bearable. Let's continue on here. We're going to take a look in this week at constructing things like lists, dictionaries, sets, and so on, and also what are called comprehensions. We're going to take a look at exceptions, which are problems that get raised when something bad happens in your program, and we're going to talk about how to deal with those exceptions to avoid having your program crash. Now, one of the common places where exceptions occur is when you're trying to get input from a user, because users do things wrong all the time. And so processing exceptions is something that you have to do a lot to protect yourself from idiot users. We're also going to take a look at defining and calling functions, storing functions in modules, and in the second half of this chapter, take a look at a very important add-on library, add-on module for Python called NumPy. Does anybody have any questions about anything before I get into this stuff? A couple people pointed out to me before class that homework assignment 3 was locked. Sorry about that. It is unlocked now. You should be able to access it. All right, so let's go ahead and get underway. It turns out that you can construct list, tuple, or set objects from any kind of iterable. And an iterable, as we know, is something that you can iterate through with something like a for loop. A list is an iterable, a tuple is an iterable, a set is an iterable. Any other examples you can think of off the top of your head? A string is an iterable, good. And a range is an iterable. Okay, that's another example. So let's suppose that we have a string and we would like to make a tuple containing the characters within that string, or I should say the one character substrings within that string. Now, since the string is an iterable, if you give that to the tuple construction function, the construction function will just step through that iterable one item at a time and generate from that a tuple of those items. So what I get for tup1 here, the variable I'm using to refer to that tuple, is the string little t, then little h, little I, little s, space, etc. Now a tuple, in turn, of course, is an iterable, and I can build a set from that. We know that a set has only one copy of unique items when you construct a set. And so the duplicates in the tuple, there are multiple i's, multiple s's, multiple t's, multiple spaces. All the duplicates get thrown out, and what I might get when I look at my set is AIESH space T, or they might come out in some other order. The elements in a set are not ordered in a particular way. And finally, or as yet another example, I might then choose to build a list from that set. And so here I'm getting ls1 containing the same items that the set contains. I'm sorting that intentionally so that it's guaranteed that the items will come out in ascending ASCII order. It turns out in the ASCII character set that the space character comes ahead of all the letters. So I get the space character first and then the letters in alphabetic order. Everybody happy? Okay. A dict can be constructed again from an iterable, but this time the iterable has to be on pairs of values, or what are called two tuples. Okay, so here I'm creating a set using curly braces, and this is a set of tuples. The first tuple in the set has little a and the value 12. The second tuple has little b and the value 22. Now the set is not going to store these in any particular order, but it does store those two tuples as its items. And when I then use the dict construction function to build a dictionary from that set, it does what you would expect. Or I'm not sure you would expect anything since we haven't talked about it before, but it creates a dictionary in which the first item in each tuple is treated as a key, and the corresponding second item is treated as the value associated with that key. Okay? So B is my key with value 22, A is my key with value 12. Now I said that you could do that with an iterable on two tuples. Actually, you can do that with an iterable on any pairs of values. So if I were to do something like this, M1 gets, and then square brackets to create a list, 5, 7.5, and then another two list, 8, hello, and then another list, 9, false. All right, so in this case, M1 is a list of lists, and each item in the list M1 is a list of two items. And dict is happy to create a dictionary from that list of lists as opposed to a set of tuples, because there are two items in each of those lists. Come on, type. There we go. Okay, so here I have the key 5 associated with the value 7.5, the key 8 associated with the string hello, and the key 9 associated with the Boolean false. Okay, so any iterable on pairs of values can be used to construct a dictionary. The zip function is a really handy function for combining together two separate iterables into one iterable on the pairs of items in those two iterables. So let's see what I'm talking about here. Actually, I'd better create these examples that I've been looking at here. Come here. All right, so tup1 is a tuple built from this is a test. And if I then throw that into a set, now, one of the nice things about a set, even if you don't care about having a set specifically, is if you just take an iterable and throw that into a set, what's guaranteed? Well, what's guaranteed is you no longer have any duplicates. So if you want to get rid of duplicate values, you don't have to write some complicated logic for that. Just throw the thing into a set, and all the duplicate values are gone. All right? And then I'm going to create ls1 from that guy as a list and sort that. There we go. Oh, I was deeply disturbed by all these duplicates. Do you see what I did wrong? I created the list from the tuple instead of from the set. So I created the list from this tuple instead of from the set, which is what I meant to do. So let me say ls1 gets a list from the set one. And now I will not have all those duplicates. for a moment there, I thought, oh, they've introduced a new feature in Python 3.7.3 that I didn't know about. Okay, so there we go. We're good now. Okay, so here's my list of these values. Now, if I ask for the range of values with the length of ls1 as my one and only argument to range, what range of values is that going to produce for me if I did that in a loop? From 0 to 6, yes, because the length of that list is 7, correct? And so 7 is one beyond what I'll actually get, so I'm going to get the values 0 through 6. Now, I can use those values 0 through 6 as keys associated with these values. Or I can do that the other way around. So if I say zip ls1 together with range of len of ls1, that's going to take the list ls1 and this range of values 0 through 6 and zip those together into pairs. So I'll have the space associated with the value 0, the little a associated with the value 1, the little e associated with the value 2, and so on. When I just hit the enter key here, it's not going to look very impressive because zip creates an object, so there's nothing much to see. But if I use that object in a for loop, let me use this zip object in a for loop, I can iterate through that. And you'll see that it's doing what I'm claiming. I guess I better print that. Okay, so each variable it is going to be set to an item coming from the zip, and what I'm going to get is space followed by 0, a followed by 1, e followed by 2, and these are going to come out as tuples. So zip is going to produce for me an iterable over tuples. Okay? Yes?
What if you're trying to zip two things that have different lengths?
Good. If you're trying to zip two things that have different lengths, the shortest one wins. All the excess stuff in the longer one is just going to be thrown out. So here I've done a zip of ls1, which has 7 items, with the range up to but not including 7, which is also 7 items. But if I said this, zip together ls1 and range 1000, and then print the item. Okay, well, ls1 only has 7 values in it. Range 1000 has 1000 values in it, but the trailing 993 are, yes, going to be thrown away. So I still get the same result. Good. Any other questions so far? Okay, well, so now I've got 2 tuples, and from 2 tuples I can build my dictionary. So I can say D2 is a dictionary built from ls1, and, well, now that I know that I can throw away, now that I know that I can ignore the trailing values, I'll just go ahead and say range 1000 instead of having to say len ls1, which I don't need that. And expected at most. Oh, I forgot zip. Thank you. Can't really demonstrate zip if I don't use zip. Thanks. So we're going to zip together ls1 and range, and I have D2 now. Okay, so space is my key with the value 0, A is my key with the value 1, E is my key with the value 2. And as you can see, if I just flip these things around, if I zipped the range followed by ls1, then I would get the other way. I would have 0 as the key with space as the value, and a is the key with 1 as a value, and no, 1 is the key with a as a value, and so on. Good? Any questions?
What happens if you try to use the dig function on a list instead of the list of pairs?
You'll just get an error. And in fact, that isn't quite what happened here, but excellent question. Let me try that. So let's say D3 gets dict. Well, let's just be safe. Let's confirm for ourselves. ls1 is a list of one-character strings. And if I say D3 gets a dict, come on, gets a dict built from ls1. I'm sitting slightly at a corner from my keyboard, and that's why. Okay, I've got to sit square here. There. Okay. So it says element sub 0 only has one item in it, but 2 is required. Okay, so in other words, element sub 0 is just the space character. It needs to be some structure containing 2 items. Anything else? Yes?
So if it is a list of lists, then it will work containing 2 items.
Yes, in fact, I did that years ago. Where did I do that? Here. Okay. So here I created M1 as a list of lists. And each list within that list of lists has 2 items in it. So M1 contains a list of lists, and if I say D4 gets a dictionary from this list of lists, it works fine. Other things? Other questions?
If the list of lists are more than 2, it won't work, right?
Yeah, if I had an item in, if my list if my list of lists contained an item that had more than 2 items in it, then dict would yell at me about that. At least I'm pretty sure. Let's confirm that. I'm not sure I've tried that particular experiment. So let me create M2. Oh, I was going to copy and paste, but I'm being stupid. I can just say M1.copy. Alright, so M2 is at this moment an identical copy, but I can say M2 sub 1 to access this list of 2 items, correct? And I can say M2 sub 1 dot append, let's say none. And now, if I look at M2, the sub 1 item within M2 is a list containing 3 items, where the last item is just none. And I believe if I try to create a dict from this, that I will get yelled at when it encounters that. Unless it ignores it. Well, I guess we're about to find out. Yeah. So it yells at me. It says that item sub 1, which is this guy, has a length of 3 and has to have a length of 2. Okay, well, let's go ahead and continue on. So we've taken a look at constructing these data structures, tuples, sets, lists, from any kind of iterable, and then dicts can be constructed from iterables on pairs of items. An iterable on 2 tuples, an iterable on 2 lists. In fact, I can do one on a list of 2 strings. This is kind of an amusing example. So let's say D6 gets dict of a list AB, CD, come on. EF, GH. Now that looks pretty fishy. I've got a list of strings. How can I create a dictionary from a list of strings? Well, remember that a string is itself an iterable. And when you iterate on a string, what you're doing is breaking it down into separate one-character wide strings. And each one of these strings I've been careful to put exactly 2 characters into. So what I'm going to get here is a dictionary containing A as a key with value B, C as a key with value D, E as a key with value F, and then G with a value H. Okay, so that's yet another way of, or yet another example of creating a dictionary from an iterable on pairs. Okay? Okay, now in Python, a beloved thing within Python world is what are called comprehensions, which are a very concise way of generating things like lists or sets or dictionaries using a for loop inside of the square brackets or the curly braces. This is referred to as a Pythonic thing, which I think of as just meaning, it's cool to do. But it is typically things that are called Pythonic or things that Python can do easily that in most other languages that are widely used is harder or more awkward to do. Okay? The basic idea of comprehension is to be clear about what you're constructing your list or set or dictionary from. But having said that, it's quite possible to create very warped comprehensions as well. So it's a kind of a two-edged sword here. Let's suppose that I wanted to have a list of int values between 0 and 15. Well, the brute force way to do that would be to just give a variable name and then type, 0 through 15 separated by commas in square brackets. Obviously that works. But a big problem with it is that it's really easy to make mistakes. Not only is it easy to make numerical mistakes, but it's, as I have demonstrated several times, easy to make silly typing mistakes, that just make it a mess to do this. And you surely wouldn't want to do anything by hand if you had, 10,000 values in your list. So instead of typing this out by hand, let's consider using a loop instead. I can start out with an empty list, and then I can, for example, use the range iterable to generate values, in this case between 0 and 15, and just append each one of those values to my list. So this way I have M20 containing a list of values from 0 to 15. It's less typing, and it's easy for me using this approach to create a list of like 1,000,000 values. I just put 1,000,000 here into my range instead of 16 into my range. But that I don't know, it just doesn't look very pretty. So the Pythonic way of doing this same thing is to use a comprehension. Basically what the comprehension does is to put the for loop inside the brackets instead of having the for loop containing the list and appending items to the list. Alright, so here is my comprehension. I'm using square brackets to create a list, and within the brackets I have an expression. Now the expression here is just a variable name, meaning that each item in the list is just going to be the value of this variable. Following that expression is a for loop that generates a sequence of values for that expression, in this case just for the variable v. Alright, so my comprehension is going to consist of a sequence of values v where v goes from 0, 1, 2, 3 up to 15 and then stops. And so that is exactly the same effect as the for loop. In other words, if I say M20 gets a list where each value in the list is going to be v for the value v taken from the range 16. Poof, there's my M20. Okay, so two parts to this thing. The first part is the expression. Here the expression is very simple. It's just a variable name, but it could be more complex. It could be something like v cubed or cosine of v, or some other function of v, or a combination of v and some other value, whatever. And following that expression has to be a for loop. If you don't have a for loop, it's not a comprehension. Okay? So you need the for loop in order for this thing to be, to qualify as a comprehension. Why do I even bother to mention that? Well, just as an alternate example, if I say M20A gets list range 16, what does that do? Well, I'm using my list construction function. Range 16 is an iterable, so I'm generating a list of the 16 values 0 to 15 using my construction function and the range iterable. Okay, that accomplishes the same thing, but because it's not using a for loop, it's not a comprehension. I wonder if you should even care. Yeah, I guess you should care. I guess you need to be able to tell what is a comprehension and what is not a comprehension. Okay, so in general, here's what a comprehension looks like. You have some expression followed by some for loop, some variables in I couldn't remember what tier meant. Well, it's a misspelling. That should say iter. So this should be saying for variables in iterable. So tier is actually iter, not tier. Optionally, you can also have additional for loops and if decisions out at the end, which will modify how the expression is computed in your comprehension. So let's take a look at some slightly more complicated examples. Here I have, well, this one's not more complicated. This one is really trivial. Here I have a comprehension in which each item in the list is just going to be the value 0, and I want 8 of them. So I'm using a for loop to generate 8 values, 0 through 7, but I'm ignoring those values 0 through 7, and I'm just creating 0 as my list item, total of 8 times. Here, I'm computing v squared for each value between 0 and 7. All right, so the values in this list M22 go from 0 squared up to 7 squared. And in this third one, I'm computing v over 2 for each value in the range from 0 to 9, up to but not including 10. However, I'm only going to do that computation and put a value into my list if the current value is odd. That is, if the remainder of the value divided by 2 is 1, if the value is odd, I'm going to divide that value by 2 and put that value into my list. But the even numbers are excluded from this list. So I just end up with a list of 5 halves of odd numbers. Does that make sense? Okay. All right. Here I'm going to import the math library so that I can use various math functions and constants. We've done this, right? You've seen importing math as M? Please say yes. Yes. Good. Now I know that it's true even if we didn't do it. All right. So I'm creating a list here called M24, and M24 is going to consist of a list of values, the cosine of pi times some value over 4, where the value is ranging from 0 to 7. So in other words, you know, I don't know how instantaneous your trig might be, but I'm computing the cosine of 0, the cosine of pi over 4, the cosine of pi over 2, 3 pi over 4, pi, and so on. And those cosines are 1, square root of 2, 0, minus square root of 2, minus 1. And is that right? Yes. 1, square root of 2, 0. Oh, oops. Kind of 0. You know, when you're dealing with floating point numbers, you never have exact values. You only have really close approximations. And so this number, 6 times 10 to the minus 17, is a close enough approximation out to 16 digits of 0. And then we've got minus square root of 2, minus 1, and so on. All right, so these values are what one would expect. Although, I guess I should point out that even the square root of 2 values are not exactly perfect. This square root of 2 differs in the last decimal place from all these other square root of 2's. So, you know, we're always getting a little bit of rounding error when we're doing floating point computations. But hopefully, if you're worried about you know, populations and diseases and money and things like that, you won't care about numbers out to 16 digits of precision. So far, so good? Okay. Now, it's not necessary for the expression in the comprehension to only yield a single value. Here, I'm doing a list comprehension, but my expression is actually creating a tuple of 5 values. So for each value v going from 0 up to 8, I'm going to compute the cube root of that number, the square root of that number squared, and that number cubed as a tuple of values. All right, so my first 5 tuple is zeros, you know, because 0 to anything is, well, we won't consider 0 to the 0, but 0 to something that's not 0 is going to be 0. And then 1 to any power is going to be 1. And then finally we get out to 8 is the last value in this list. The cube root of 8 is 2. The square root of 8 is 2.828. And then we have 8 squared, 8 cubed in that final tuple. So this list comprehension notation is very powerful. You can use it to create lists of individual values, lists of sets of values, lists of pairs of values, lists of tuples of values, you know, using arbitrarily complex calculations and so on. Any questions?
Can you use if inside the...
I'm sorry?
Can you use if statement inside as well?
I didn't quite hear that. I'm sorry.
Can you use if statement?
If statement.
Inside.
Yeah. Yeah, I think we showed one example of that. Yeah. Here we showed an example where, oh wait now. Is this the example? Is this what you meant? Using the if out at the end of the for?
Yeah.
Okay. I wasn't sure whether you meant using it there or using it over here in the expression. Turns out you can use it in both places. Any other questions about this list comprehension idea? Okay, you can also create a set comprehension by just replacing the square brackets with curly braces, and that will create for you a set of values instead of a list of values. And of course, any duplicates will be thrown away that way. It's also possible to create a dictionary using a comprehension. Just like with the set, you use the curly braces, but to distinguish the dictionary from the set, you have to remember to use a colon in your expression to separate the key from the corresponding value associated with that key. So here my variable k is going from 0 up to and including 7, and I'm building a dictionary where 0 is the key for 0, 1 is the key for 1, 2 is the key for 2 squared is 4, 3 is the key for 3 squared is 9, okay? And so, the key 7 is associated with the value 7 squared is 49. And you just need to remember to use that colon. Okay, so the colon in there is how you get a dictionary rather than a set. All right, so that's we could probably spend the entire remainder of the course doing more and more and more complex examples of comprehensions, but do you get the general idea? Are you okay with so far? Okay. Next up, we're going to take a look at exceptions. An exception is caused when some sort of otherwise fatal error occurs in your program. An obvious case is dividing by 0. If I say 7 over 0, well, that's not allowed. And if you actually had that in a program, your program would die. And what happens is you get a 0 division error exception raised. Okay? If I try to create a dictionary and I give an improper argument, instead of giving an iterable on 2 tuples, I give just a value, then that throws or some languages calling it throwing exceptions. Python calls it raising exceptions. So that raises a type error exception. If I try to convert some bogus string into a float, that raises a value error. And if you attempt to access a file that isn't where you claim it is, you'll get something called a file not found error. So these are all kinds of errors that it's very common to have occur in a program, especially when you're dealing with user input or files on disk. And you need to know how to be able to deal with these exceptions so that your program doesn't die. The way you deal with exceptions is to indicate that you want to try to perform some block of statements. When you say that you want to try a block of statements, that implies that you fear that that block of statements might not work. Okay, so we're going to try to do something. We fear that that might actually fail, and if an exception occurs in that stuff that we're trying, we can grab the exception by using the except keyword with a colon after it at the bottom of our try block. Okay, now you can I was going to say expect, but no, we're not trying to expect things. You can catch individual exceptions. You can say except space key error, expect case space value error, expect space type error to catch individual kinds of exceptions. But if you just say plain old except with a colon after it, then any exception that occurs within the try block will get caught at that point. Okay, so here I'm intentionally doing a divide by 0 error. That will definitely raise a divide by 0 exception, and so the variable val is going to get set to -1. And sure enough, if I look at val after this try except code is finished, I'll see that it's -1. Okay, so I can type this stuff in manually. Let me say val gets 1234. And then we're going to try... we're going to try to type try. We're going to try to compute val over... or we're going to set val equal to 7 over 0. We do expect that that's going to raise an exception, which is going to be the divide by 0 exception. And if that occurs, I'm going to say val gets minus 1.0. Let's see what val is. Yeah, so val is referring to the value minus 1.0. So that does imply that an exception occurred. But I was able to capture that exception by using my except block. So in some languages, this business of what's called catching thrown exceptions is considered to be a sort of a kludgy way of handling errors, but in Python it's just what you're expected to do. Okay, so I don't know what the, it's a some kind of cultural difference, I guess. But using try to attempt to do various things and using except to clean up after problems is something that you're just assumed to be doing in a lot of Python programs. Any questions so far? All right. So now that we know how to handle exceptions, we're ready to try to deal with nasty, awful users who do like to make all kinds of mistakes. If you want to get user input into your Python program, a typical thing to do is to use a function called input, which waits for the user to type a line of input and then press the enter key. The input function will then return whatever the user typed as a string, that is, as a stir object. I don't think we've talked about input before, but I could be wrong. Have we talked about input before? No. Good. Okay. So let me just do a couple of live demonstrations of input. If I say A gets input, just like that, now the input function is going to pause and sit and twiddle its thumbs waiting for the user to type some stuff. And so I'm going to say hello world and press the enter key. When I press the enter key, the input function gathers up everything I typed. It actually pulls the new line character off the end. So when I pressed enter, which is represented as a new line character, the input function automatically takes that away. And my variable A now contains the string, hello, comma, space, world, with no new line. There's no \n on the end of that input. So far, so good? Now, the user is going to be very puzzled if your program is running and then all of a sudden just pauses for no apparent reason. So rather than using input with no argument, it's a lot more common to use input with an argument. Please enter a line of text. Okay, if you give a string as an argument to the input function will display that string as a prompt, and then it will sit and wait for the user to type something. I put in a space here after the colon intentionally, just to make my prompt look pretty. I hit the enter key and please enter a line of text. I can actually follow that instruction. Hello world, and now I press enter, and B contains what I typed, hello world. Good? Okay, so we're going to ask the user for some input. Now, in the examples that I just showed you, I asked the user to enter, any old text. But often you'll ask the user for a numerical kind of input, like, what is your bank balance? How many people are in your department, et cetera, and you will want to convert the string the input reads in to an integer value, to an int value or a float value that you can actually do arithmetic and comparisons with. Okay? And these conversions can fail. If the user types bogus input, the conversion will fail, and that will raise an exception. So we're going to ask the user for some input. We'll attempt to convert that input to the format that we want. We're going to have to do that in a try block so that we can use except to handle bogus formatting values that the user typed in. Even if the user types a correctly formatted value, like if I ask the user, what is your social security number, and the user types a 4-digit integer, well, sorry, that's not a social security number. I don't care what those numbers are. I mean, a social security number in the US has to be 9 characters, 9 integers, period, all right? So if you only type 4, if you type 10, that's not valid. So we'll use some regular logic to deal with range check kinds of problems. All right, let's take a look at a program that's doing this kind of stuff. Yes, page down, I said. There. Okay, so I have posted on Canvas this little program called UserAge, and let me pull that into an editor here. Aha! I stupidly forgot to install that. So, not to worry. We'll rush to Files, Lecture Support Files, UserAge. There we go. And I can download UserAge. Alright, and now I'm going to put that in the right place. Okay, so I'm deleting it from download, and I'm going to put it into... Oh, that's my videos. I don't want that. Alright, so I'm putting this into my DFP A1 2019 directory. Okay, so now I've got it in the correct place, and now I can open it. There we are. So there is the entire program. It's not very long. What it's going to do is to ask the user to enter their age. Then it's going to check the format of what the user entered to see whether it's a valid number, a validly numeric thing. And finally, if it is a valid number, we're going to check to see whether the age makes any sense. If the user types 0, no, that doesn't make any sense. And if the user claims to be older than 125, we're not going to accept that either. Maybe somebody's lived that long, but I think current scientific thinking is that 120 is about it. All right. So if the user enters a negative value, if the user claims to be 1,000, we're gonna complain at them. All right. Let's try this out. I'm going to run it. Enter your age, and I'm going to say 1,234. No. Enter a value greater than 0 and less than or equal to 125. All right. Minus 10. No, that's no good. 46. Oh, that's a bad format. All right. The conversion function is not smart enough to convert text, even though that text represents a valid number, into numeric. So if I really want to claim to be 46, I better say 46. That's a lie, but all right, whatever. Okay, so I typed something that was a number and that was also in a valid range, and so finally my program accepted that number and is now gonna, I don't know, tell my fortune or something. Okay, let's take a look at how that actually works. So in this little chunk of code here, we're going to assume initially that the age the user types is bad, right? And we're using a while loop here saying while the age is bad, that is, while the user typed something that was either not a number or outside our range, keep asking the user over and over until eventually the user complies. Okay, so while the age is bad, ask the user, enter your age. Input will wait for the user to type some input, and that will come back and go into this age stir variable. I'm then going to attempt to convert that string into a float. And that conversion will only work if age stir does represent a valid floating point number kind of format. So when I type the words 47, the float conversion function is not smart enough to understand how to do that. And so that threw a, well, let's find out what it, that raised an exception. Let's find out what it raised. So if I say float 6, let's say, yeah, so that raises a value error. Could not convert the string 6 into a float. Whereas if I had said float 600.0 times 10 to the minus 2, I don't know why anybody would enter their age that way, but float understands how to do that conversion. And you know, and that just converts to 6.0.
Do we have leading or trailing spaces in that?
That's an excellent question. I don't think so. I'm sure I tried that experiment once upon a time, but I don't remember what happened. Maybe it will handle that okay. Yay, it does. Okay, so apparently if you have leading white space or trailing white space, yay, it's happy. I'm sure I knew that years ago, but I don't remember now. Good. Any other questions so far? Okay, so 600.5 does convert to a float just fine, but then I would run afoul of my ordinary range checking logic. Okay, because 600.5 is definitely not less than or equal to 125. So I would get this message saying enter a value in the range greater than 0 and less than or equal to 125. This is bad programming on multiple levels, and if you're trying to write a user-friendly program, because you know, bad age format is a kind of insulting thing to say to the user, not very informative, and it's probably not a good idea to assume that your user understands what a half-open numerical range is. But I needed something that would fit on the screen. Okay, so we're going to try to get the age and convert the age to a float. If that fails, we'll tell the user bad age format, and we'll randomly or arbitrarily set the age to something that's bogus, -1. Then we'll tell the user to enter a value that's in the valid range, If everything went well, however, we're going to set age bad to false so that our loop terminates. Okay, because our loop is running as long as age bad is true. But when the age bad becomes false, we'll fall out of our loop and we'll tell the user what their age is. All right, so let me run this another time. Enter your age, and 0.012. Hey, I guess I moved my mouse out of the window. 0.012 e plus 2. No user but a computer geek would type something like that, but that does represent a valid floating point number as a string, and so I get told, okay, your age is 1.2. So it is converted to a float. It is greater than 0 and less than 125, less than or equal to 125, and so my while loop terminates, and I get told my age is 1.2. So users are kind of awful. You have to write a lot of code to protect your program from users. Any questions? All right, so we've looked at try and accept, and we've looked at the input function and conversion. That was kind of the main thing going on here. All right, now we need to know how to define and call our own functions. We've looked at things like print and input and cosine and whatnot. We have defined really trivial functions before, right? That just take positional arguments and do little computations. No? Sorry. Different class. Okay, so to define a function, you start out with the def keyword, def for define, and then you select whatever function name you like. The rules for function names are the same as the rules for variable names. So the first character has to be an upper or lowercase letter or an underscore, and then subsequent characters have to be either letters or underscores or digits. Following that name that you chose for your function, we have a pair of parentheses. And within the parentheses, if you want the function to be able to receive arguments, you need to specify parameter names into which those argument values will get deposited. In Python, it turns out there are two different flavors of parameters that you can pass to a function. One are the so-called positional parameters that just line up from left to right. So we've got argument numbers number 1, argument number 2, argument number 3, etc. The other flavor of arguments are what are called keyword arguments, and those have the form name gets value, where value is a default value that's used if the user did not specify. Let me do a little demo here. When I say print 5, it is odd, those are two positional parameters. 5 is the first parameter, is odd is the second parameter, and we know what the print function does by default is to convert the 5 to a stir and print it, and then is odd is already a stir, and that will get printed, and a space gets put in between them, correct? By default? So I've got 5 space is odd. We have, I hope, talked about the sep parameter. Have we looked at that? Yeah. So sep is an example of a keyword parameter. The default value of sep, if you don't specify sep yourself, is space. So that's why you get spaces out between the values. But if I define a value for this keyword parameter sep, of comma, then I will get a comma displayed between 5 and isOdd. And there's really no limit on what you can do with that sep as long as what you do is a string. Sep gets so you can specify any separator string that you want, and it will get put in between the 5 and the isOdd. So this little illustration shows a print function taking two positional arguments, two positional parameters, and one keyword parameter. So that's how, if you want to define a function of your own, you can set up parameters to receive both positional values and keyword values. Okay, for the keyword, you have to specify the name of the parameter and what default value that you want to have. So in the Python internal definition of the print function, what it says is def print open paren and then space for positional parameters, and then at some point it says sep equals space, a string containing a space, because space is the default. But now I, as a user, when I call print, I can say sep equals something else. And you can have as many of these keyword parameters as you want. Now, the rule is that if your function takes a combination of positional parameters and keyword parameters, the positional parameters have to come ahead of the keyword parameters. Right? So you've got all your positional parameters first, and then all your keyword parameters after that. Here's a really simple little example called retpow. And what this function does is to return the first argument, which is named x, the parameter x contains the first argument, to the power of the second argument, which is y. I've specified a default value for y of 2. So if I say def retpow x comma y is by default 2, I have to give a colon at the end of my def line. I think I forgot to say that, but you do have to have a colon at the end of that, like you have to have a colon at the end of for or if. And then the body of the function has to be indented, and so what I'm going to say here is to return x to the power of y. My function is now defined, and I can say retpow 3 to the 4th. Okay, so that's going to be 9 squared is 81. So retpow of 3 to the 4th power should give me back 81. Yay! If I just say retpow 3, then what default exponent do I get? 2. The default exponent is 2, so this is going to give me back 3 squared is 9. If I say retpow 5, y equals, well, I have to have something I can do in my head. 3. I can compute y. I can compute 5 cubed in my head. All right, so here I'm specifying the name y and the value that I want y to have. Up here, it turns out that because y was specified as the second parameter, it gets this value 4, even though I didn't say y equals 4. All right, so 5 cubed, it better be 125. Yay! I'm so proud of myself when I can do simple arithmetic in front of people. And in fact, you can specify the name of positional parameters as well. So I can actually get away with saying y equals 3, comma, x equals 4. 64, I'll bet. So 4 cubed here is going to be 64. Notice that by giving names of both of them, I was able to swap the order around. But the rule, as I said, is that you have to have when you're typing in values, you have to have all of your keyword arguments before. Saying this backwards. You have to have all of your positional arguments before your keyword arguments. So here I have a positional argument, and I have another positional argument sort of masquerading as a keyword argument. 4 becomes the value of y. Here I have the positional argument, and the keyword argument y as the default value of 2. Here I have a positional argument and an explicit keyword argument with a value of 3. Now down here, this may look like it's violating my rule, but in fact, I'm treating both y and x as keyword arguments, and so I can put those keyword arguments in whatever order I want. They just have to come after positional arguments. Here's what I can't do. I can't say retpow y equals 3, 2. That I can't do, because now Python is going to be angry and say, no, you have a positional argument after a keyword argument. Okay, so the common thing that people would actually use here are either just use the default, which is 2, all right, so retpow 3 gives me 3 squared, or name the positional argument as the second argument. Those are the two most common styles that people use for calling functions that have a combination of positional arguments and keyword arguments. Okay with that? Okay. Here are more similar examples of what I just showed you. These functions, this function retpow that we just looked at, requires one positional parameter and allows one keyword parameter. But if I attempt to call retpow with no positional parameter, that's not valid. If I attempt to call retpow with too many positional parameters, that's also not allowed. So if you have a fixed list of positional argument parameters and then keyword parameters, the user has to call the function giving exactly those correct positional parameters in the correct order. That's what positional means, is they have to be in the correct order. Okay? It turns out that Python allows you to define what are called variadic functions, which are functions that take a variable number of arguments. To do that with a variable number of positional arguments, we're going to use the special argument *args at the end of our list of named positional arguments. All right, so here I'm creating a function named veryFun. veryFun has 3 positional arguments that are required. So when I call veryFun, I have to give 3 positional argument values. Optionally, *args will collect all of the other positional arguments that I type when I call this function. And it turns out that *args is a tuple of all those trailing values. All right, so let me type in this veryFun function. VeryFun, A, B, C, *args. And all I'm going to have the function do, just to illustrate how arguments are passed, is I'm just going to print out A, B, C, and args. All right, so if I now call veryFun and I pass 1, 2, well, that's an error. I've got to have at least 3 positional arguments. So I'll try veryFun 1, 2, 3. Okay, that worked fine. I got A, the parameter A set to 1, or referring to 1, B referring to 2, C referring to 3. Now, args here is a tuple, but it's an empty tuple because I did not type any more positional arguments. If I said, let me grow my window a little bit so we can still see the function up here. If I say very fun 1, 2, 3, 4, 5, 6, 7, hello. All right, what's going to happen now? Well, these ordinary positional parameters, A, B, and C, are going to get these first three values, 1, 2, and 3. The args tuple is going to get all the trailing arguments here. So I'm going to end up with args being a tuple of 5 values. Integer 4, integer 5, integer 6, integer 7, string hello. And it's fine to have, mixed data types in a tuple. That's no problem. And so here is my tuple args containing those trailing positional arguments. Okay with that? Okay, so this gives you a lot of power now if you want to be able to create functions that take some arbitrary number of arguments. Like if you want to create a mathematical function that accepts 1 value or 2 or 9 or 1,000 values, you can use args for that purpose. And then once you get that tuple that contains all those values, you can use something like a loop to step through all of the values in that tuple. In fact, here's an example. This is a function called mySum. It takes a varying number of arguments, and the first thing it's going to do is to print out the tuple containing those arguments. Okay. Then we're going to compute the sum of those arguments in a fairly trivial way. We're going to assume that the sum initially is 0. By the way, that means that if you call mySum with no value, it'll return 0. It'll tell you that mySum of nothing is 0. I guess we can argue about whether that makes sense, but whatever. Okay, so we'll start out with our sum at 0, and then for each value in args, for each value in the tuple, we will accumulate that, add that into our sum, and return the sum when we're all done. So you don't need to define such a function yourself, because there is already a function that works fine. Let me say T gets tuple range 1, 7. Okay, so T is the values 1 through 6. Actually, I guess I need to manually type those in, so having that tuple doesn't do me any good. So the idea here is that, sorry, I'm being very clumsy. All right, let me just hope that you will trust me that this thing works. You can type it in, you'll see that it works. What I was trying to get to is that it turns out that Python already has a built-in sum function. Although this sum function does require an iterable, and it will compute the sum of the values in an iterable. All right, so I'm not suggesting that you are going to want this mySum function yourself. I'm just using it as an illustration of how to use the star args variadic positional parameter. So far, so good? All right. You can also have variadic keyword parameters. Now, for keyword parameters, we have both a variable name and a default value. It turns out that KWArgs is the conventional name people use for variadic keyword arguments. That thing has 2 stars in front of it. And what you get in place of star star KWArgs is a dictionary where the variable name is the key and the default value is the value associated with that key. So here I have this function VF2 that has one example of each of the kinds of parameters it's possible to be passed. I have an ordinary positional parameter, A. Then I have my variadic positional parameter, star args. Following all the positional parameters, I have one keyword parameter, B, with a default value of 42, followed by the star star KWArgs, which is my keyword arguments dictionary. And let me type this guy in. So this is VF2. All right, so we've got A, star args. B is 42 by default. Star star KWArgs. And I'm just going to print these out so that you can see what's being passed in. So A, args, B, KWArgs. If I call this by saying VF2 1, 2, 3, 4, 5, B gets 19. Well, 9 is good. And then C gets true, D gets hello. All right, I have my positional arguments first, 1, 2, 3, 4, 5. Now A is going to receive the value 1. Args is going to be a tuple containing 2, 3, 4, 5. B, instead of being 42, which is what its default value is, B is going to be 9 instead. And KWArgs, the dictionary KWArgs, is going to have 2 items in it. There's going to be the key C associated with the value true, and the key D associated with the value true. Now, because of the rules for parameter names, where every parameter has to start with an upper lowercase letter or a digit, it's perfectly fine to just treat variable names as strings. So in the dictionary, there's going to be quotes around the C and the D. But they are nevertheless how these variables C and D are represented. And there we are. All right, so there's the value of A, which is 1. Here's the value of args, which is the tuple 2, 3, 4, 5. The value of B is the value that I specified, 9. And the value of KWArgs is this tuple with keys C and D and associated values true and hello. All right, so between ordinary positional parameters, ordinary keyword parameters, and then the variadic positional and variadic keyword parameters, you have an enormous amount of control over how you want to allow some user to pass stuff into a function that you define. Okay? Any questions? This is something that you kind of have to putter with and try out. There might be something in the homework having to do with experimenting with this. Okay. All right. Well, this is a good place to take a 10-minute break. So let's do that, and then we'll continue with this stuff.